get an interface. The VLSI people wants to get an interface between quantum and classical domain, with the only problem being is like once the information is out from the quantum domain, it is measured, it is lost. As far as the like the technology stands or the postulate stand right now, once you have measured, it is no longer probabilistic. You know what is the value. So, which means in quantum aspects, it is lost. In terms of our photonics, is like annihilated, destroyed. And the operator is also called annihilation. So, what you call as detection or measurement, we call that as annihilation of the photon. And hence the name of the operator. So, people are trying to get this interchange between hybrid, but so far, it will be one unidirectional. So, if it goes out from the quantum domain and enters the classical computer, there's no way of getting it back. So, but on the other side can happen. Now, fault-tolerant quantum computing, this one is practically has a lot of research going in at every aspect. This is practically the one which is, in terms of the research, which has got many nitty-gritties into it. Especially hardware, producing, as we say, well-behaved qubits. So for that, you have to get out a good photon or a good fermion out, like I'm calling it fermion in general, whichever has a Fermi level into it. So a good photon or a good fermion can go out, and so different kinds of research, like NV center, diamond NV centers and things like that. From various aspects are solving before the measurement part. So making qubits, sending the qubits, increasing the lifetime of the qubits and all that stuff. So, and keeping the qubits safe as much as possible from the environment. I mean, right now the trouble is like to help the qubits not get lost into the environment. They're very sensitive right now, like you college kids. So, room temperature quantum computers, as I said, like at the beginning. So, people have been trying to move out of cryogenics because it itself involves a whole system or a their only job is to bring temperatures down or enclose low temperatures inside a canister or something like that. So room temperature quantum computers are being approached by finding new materials or fabricating new materials, mix and match everything which would stay in its form in room temperature, which practically gave out the importance of the photonic quantum computers because you don't need a cryogenics over there. Instead, what we have found out, it works well under vacuum, which is easier to make. So quantum as a service, now IBM is sort of regular to me, which is a good news to you. And IBM, I think one speaker came who also spoke of quantum computing. So all the major players are trying to get a hand on quantum computers. What do you call that? Outcomes of them are technologies like time crystals. So Microsoft or Google made the first, designed the first time crystal on a quantum computer, which is supposed to be a perpetually running machine, which probably Tesla thought of. So it keeps fluctuating all the time. Now that one took the reviewers to around 2 years to understand the paper. So yeah, that's like a new kind of stuff. The more fascination is about what can. Yeah, but the direct application of that one is in clocks and things and space applications mostly. And quantum safe encryption. So we have a war going on. People who are warring have quantum computers. I don't think India still has a functional quantum computer yet. Yes. Yes. So if anyone is charging a missile at us with a quantum encrypted missile, we have to just sit down and catch the missile and hold it in our hands and we'll play with it until it blows up. So that's one of the drives. So the quantum safe encryption, as in is the other way around. You try to break the quantum key. So probably a projection would be to make a more dangerous environment to break it down, the phases and all that stuff. So I think we human beings are much better at making more chaos than order. So that should be a good thing. Right. So from the business trend, this is a particular company. I did not try to hack our speaker's website to get business trends from ID Techs. So obviously they have seen their quantum service sector increasing, starting to increase as a like in a more exponential manner. At least so practically we are standing over here. Obviously those are projections. This is thought of to happen by 2030. I think 2030 is the happens. Some of the market size, these are like proper market research data in terms of USD and where different places are standing by color. So obviously, I think the Asia Pacific is rather increasing more rapidly, which may be news to you compared to USA. Which tells me it's a good time to grab it if you're into business. And this is like by sector and service, like quite a few companies. I mean, there are more companies than that. I think there's around including funds around 250 odd startups on there. So yeah, I've been telling this in various student talks. So there's a proper data from the speakers, like they're already registered as 250 startups under the National Quantum Mission. Around the world, this is the scenario. Obviously, NVIDIA has been going in for a big time. They have been on news with all of this. So in case your organizers share this one, you know where to apply. And by market and application, the services segment is supposed to increase many folds, which is the green part of it, compared to the application software and system, which is obviously application software you don't need to make every year. So it will settle down at a point with the small changes into it. But the services sector, the features into the applications, etc., has to increase, which should increase more than the other sections. Now, having said that, the future of quantum computing, so this is a paper from the archive. I think they're still publishing it. I don't know. I mean, the founder is a. I mean, you can search this one. This is practically this paper is a discussion between two gentlemen. The machine learning aspect, once again, I mean, they have been discussing about like how much of the machine learning, AI, etc., would be affected. But my take would be they would merge up very quickly, and the conscious computing would be enabled there from the simple point as like the conscious computing nodes use entanglement, mostly intra-entanglement in the system rather than inter-entanglement. So I would say these are transient talks about the trends of the future for this one, but as far as the academic trends are concerned, we are looking at like good qubits that will stay for a longer time in the system under superposition or entanglement. So with that note, I'll end my talk and give a little introduction to your esteemed speaker. So Mr. Karthikeyan Dure, our esteemed speaker today. He is founder and CEO of Quantum G Research Labs Private Limited, Bangalore. He works on applied quantum computing and quantum machine learning and experience with frameworks such as Qiskit and Penny. So with that note, I'll probably transfer to the organizers to arrange for the speaker.
Thank you, sir. Yes, so now we have Mr. Karthikeyan Dure from Quantum G, as far as mentioned. Yes, sir, again, lovely speaking. Thanks a lot for being here. Sir has helped us out a lot, and sir, we are extremely grateful that you can make it here.
It's a pleasure to present here second time. Last time I came on a hands-on workshop. Now also I'm planning a hands-on workshop, that's why I informed the organizer delegates to come with laptop such that they can practice something today. Because that gives some more value addition if you are planning your research or paper publication or project using quantum technology. Sir gave a really great introduction about what is happening, what is successful now, and how industry is expecting academia to collaborate. So I came here to share what we are expecting from you. Can I start? Yeah, please. So now to start with, I will. I like chalkboard and chalkboard and blackboard. Let me write here. So there is this says FTQC, noisy intermediate scale quantum computing, which is as of now whatever quantum computers we are having, they are all falls under NISQ quantum computer, and we are eagerly waiting for fault tolerant quantum computing, because then only we can build industry quality solutions for production systems. That is what the industry is expecting from researchers. Can you build a fault tolerant quantum computer, which means the qubits are not going noisy, they are not decoherent easily, or they are not their results are somewhat reasonably deterministic. We know quantum is not deterministic, probabilistic, but can we get a reasonably deterministic output from probabilistic nature? That is what. When it comes to industry current demand for the workforce, that is what students are more interested in. The first requirement always falls into quantum machine learning. Then quantum inspired ML optimization. So the quantum inspired is one approach which has gained a lot of popularity these days. Many industries are eagerly waiting for, can we have a production system which is utilizing quantum technology from the algorithm perspective, not on the hardware perspective, because hardware is not ready. We know hardware is NISQ. Considering that one, there are few platforms. Microsoft QAO, Toshiba, SQBM Plus, Fujitsu, Digital Alibi. Yeah. So these are all three platforms which are promising quantum inspired approach. Can we start practical immediately as of now? If you prefer. Right. Since you have already knowing Qiskit, I can straight away jump into that one. All of you either you can go to your Google Colab or your local environment. I'm not sure which one you are using. You can start either Google Colab or your local Qiskit environment. How many of you are using local environment? That's great. Good. How many of you are using Linux systems? One. That's all. No. You are also using Linux, no, right? My recommendation: switch to Linux when it comes to quantum. Not only for quantum, for any serious development, switch to Linux. That will be always what industry is working on production systems using Linux one. Oh, almost. Yeah. Ubuntu is a good start, but when it comes to the production deployment, it is not Ubuntu. It may be RHC, Red Hat Enterprise Edition, or something. Is it coming? Or else I have to connect it right. This is right. Is this? You can comfortably start with Ubuntu. So now, since the configuration is going on, we can start with the simplest one. I believe the single qubit circuit and all, you can do it on your own. Can I assume that way? For example, if I give you a circuit like this, NOT gate followed by Y gate followed by T gate and circuit operation. If I give a simple circuit like this, a 3 quantum gates on single qubit, can you write a program for this immediately without referring anything? Oh, if that is the case, personally I feel that all of you must be confident and fluent enough to write this program on a paper using pen. Because you cannot control C, control V there. Am I making sense now? Yeah, sir. Great.
Would you like a mirror or
Mirror.
mirror?
Keep it mirror. Because I am going to walk through the coding. How many of you are comfortable writing this circuit now on paper and using pen? Okay. I expected that is not a surprise to me because we never thought that programming need to be right on a paper. It is always meant to be control C, control V. And that is smarter way, right? Because we are leveraging what someone already did. That is acceptable in industry also. Industry is not expecting you to reinvent the wheel. We want to go faster. Just leverage. Control C, control V. But mentally you should have the picture. This for this requirement, this is the code block. These are the sequences. That should come in your mind. If that is not coming in your mind and then you are doing control C, control V, you are going to waste time. Meaning that you will start faster, but you will finish last, or it will take more time to finish because you don't have the mental picture clearly. So that's, I will give some introduction, some setup. So circuit design, there's execution, visualization. These are the 3 code blocks. And at the end, we have to do interpretation with our team or internally in our mind. This interpretation is the one of the most difficult part. Like the circuit designing. Someone has to design the circuit, then only you will Write a program to design the circuit, execute the circuit, and visualize it. Am I right or not? If someone gives a problem, for example, an optimization problem or material science problem or computational chemistry problem, how will you design the circuit? That is the biggest challenge among those learners because they are not able to connect the dots. For which operation, which gate is suitable? My kind request is that at this stage, put it aside, meaning that put it into the others basket. You focus only on this one. Someone will give you the circuit. Your responsibility is write a program to design, execute, visualize. Then the scope is reduced. You can focus on that scope. Acquire that skill. Become fluent. Anyone is able to give you a circuit, you are able to design, run, visualize. Keep that as a scope. Become expert in that one. After that, you can explore how to design the circuit on your own. That is what we are recommending to our interns and then juniors. Because we need the things to be done faster. Right? We have mathematicians, physicists who are going to design the circuit. We are expecting the software engineers to do this task. Is that clear? So don't enter into the how to design the circuit part now. If someone gives the circuit, how to write the program now. That is what I am going to show now. No problem. No problem. It's okay. I can manage. I will understand how it is. Okay. Otherwise, you have to keep that.
Just one person's to you.
Okay. Now, do you expect me to write this program from scratch now? Or you don't want, right? I can directly jump into the quantum machine learning. Quantum machine learning, which one you want to learn? QSVM, or quantum neural network, or quantum transfer learning, or quantum reservoir computing. Out of these four, which one you want to learn? Neural network? Is that okay? We can start with neural network? Very good. Neural network, I am going to stay with IBM Qiskit. Actually, if you prefer, you can remove this one. I will use the board itself. Surprising to see learning quantum neural network IBM Qiskit using the blackboard. All of you know how to import IBM Qiskit machine learning, right? In IBM Qiskit machine learning, there are three components. One is quantum NN, other one is estimator PNN, third one is neural network classifier. These are the three IBM Qiskit objects from Qiskit machine learning. You can import this quantum neural network, estimator PNN, and this neural network classifier. Let me start with quantum neural network. Later I will share you the program. Okay, first I will explain the concept, then I will share the program. That time you can start practicing because it needs some theoretical aspects. So in the quantum neural network, it has three parameters. One is circuit, other one is weight, input, second one is weight. There is one more parameter that is optional we can deal. I will give you a simple circuit. Start with the 0 gate, right? Let's say only 2 qubits. Let us stay with the 2 qubits. And you have Harvard gate, followed by some alloy gate, maybe theta 1, theta 2. This looks familiar? There is no difficulty in this one, right? This portion is called encode. For simplicity, I am using.
This is HOD, sir.
Okay, sir. So this portion is called encoding. After the encoding, I have to build the real neural network infrastructure. So the neural network infrastructure will start with some RZ omega 0 rotation, RY omega 1 rotation. Then there should be some entanglement. Then the next layer, you can keep any rotation. Even you can go with the P rotation also or CP rotation also. But I will keep it as another RY rotation, omega 2, then RZ rotation, omega 3. Then I can have another entanglement. This is my hidden layer. Then output layer is measurement. So this is